Welcome to the second video lecture. This will deal with vector analysis. We'll look at scalars, vectors, components, and how to add vectors. A scalar is any quantity that has magnitude or size. Examples of scalars are mass, length, speed, power, pressure, and energy. A vector, on the other hand, has magnitude, but it also has direction. It's more specific. Examples of scalars are velocity, acceleration, force, momentum, and work. Pay attention to how these are written in your textbook and how your teacher is also going to write them sometimes up on the board. When adding two vectors, you add them as if they are the two sides of a triangle. This will yield the resultant, which is usually, not always though, the hypotenuse, if the vectors are in very different directions, or sometimes if you're subtracting vectors, the resultant can be a different side. The two tools that you will use to add vectors are the Pythagorean theorem, a squared plus b squared equals c squared, and trigonometry, the relationships of sine, cosine, and tangent. For these two vectors down below, a and b, they add together to yield the resultant of r. Let's let a equal 7 and b equal 3. On your own right now, take a moment and see if you can calculate both the magnitude, size of r, and the angle, theta, using both the Pythagorean theorem and trigonometry. In order to find the magnitude or size of the resultant, we're going to need to use the Pythagorean theorem. This says that a squared plus b squared will give us r squared. So, the square root of a squared plus b squared will equal to r. In this case, if we let a equal 7 and b equal 3, 49 plus 9 is 58, and the square root of that will give us 7.6. In order to find the angle, theta, you can use either sine, cosine, or tangent, since we now have all three sides of the triangle. But, assuming, let's say, we didn't solve for the resultant yet, the magnitude at least, let's use tangent. The tangent of theta is equal to the opposite over adjacent, in this case, b over a. If we take the inverse tangent, we will have the inverse tangent of b over a is equal to theta. If we were to solve this out using our calculator, we get an angle of 23 degrees. This is 23 degrees above the positive x-axis, or you could say 23 degrees north of east. If you notice here, the north-south directions are along the y-axis, and the east-west directions are along the x-axis. There are two main visual methods to adding vectors. The first is the tail-to-tip method. You take the first vector, and at the tip of that vector, where the arrow is, you attach the tail of the second vector. You then draw the resultant from your starting point to the tip or ending point on your second vector. This is very useful when adding multiple directions, or for vectors for when you have multiple vectors for a continuous path. The second method is known as the parallelogram method. This is very helpful during free body diagrams or anything involving forces that act on the same object. You align both vectors at the same starting point, and from them you create a parallelogram, hence the name, by drawing lines on opposite each vector to create that quadrilateral. The important thing with the parallelogram is to make sure when you draw in your resultant, it begins at the same starting point as your other two vectors. Too often, it is drawn in incorrectly, going from the tip of one vector to the tip of the second vector. Make sure to pay attention to that. You are free to use whichever method you want or find easier. Any vector in 2 dimensions has 2 components, an x component and a y component. Each one of these components is parallel to their respective axes. In order to determine the components, you will need to use some trigonometry and have at least the magnitude and angle of that vector. When adding components back together, you should get them to equal the original vector, much like what we did before with vector addition. For any vector in 3 dimensions, there is a third dimension called the z-axis, which in this case, the positive z-axis comes out of the page and the negative z-axis goes into the page. We will talk about this more in class, but you will not have to do any problems in 3 dimensions for the AP exam. Here, we want to add 2 vectors that are not parallel to any axis. Vector A is closest to the x-axis, vector B is more vertical and closer to the y-axis. They combine together to equal the resultant vector C. In order to add these 2 vectors together, A and B, we need to first break each one into its respective components. We then look at the components in each direction separately. So we will add all the components in the x direction and all the components in the y direction. For example, on the bottom here in the second picture, we have AX and BX, the components of each one of those 2 vectors. Those will add together to equal the C component in the x direction. And on the vertical side, we have AY and BY. These add together to equal the C component in the vertical direction, giving us our resultant vector C. Here is another example for adding 2 vectors. Vector A plus vector B is equal to our resultant vector C. In addition, we're also given the angles for vector A and B. This will help us to determine their components. Once you have the components of both A and B, you can then add those components in the specific directions, so all the x direction components first, and then all the y direction components, in order to determine the parts or the components for vector C. Once you have those 2 components, you can use the Pythagorean theorem and trigonometry to determine the angle for vector C. So let's let A equal to 10 and B equal 8. The last thing that I would like for you to do tonight is find C. Please make sure to show all your work in your notebook and bring it into class tomorrow. Thank you very much, and have a good night.